In the world of oil and gas, you think of threats as these massive, high-pressure events. But what if I told you the most dangerous threat to a multi-billion-dollar pipeline operation, the one thing that can trigger shutdowns costing millions a day, is something so small you can barely even see it? So what really has the power to just choke off the flow, corrode solid steel from the inside out, and bring the whole operation to a grinding halt? No, it's not some catastrophic malfunction or a big geological event. It's way, way smaller. That's right, a single drop of water, but multiplied millions and millions of times over. You see, when water gets into the vital chemicals we use to prevent freezing, it's like a clot forming in an artery. It just silently weakens the system's defenses until everything just stops. All right, so let's dig into this hidden threat, and more importantly, how we fight it. Here's our game plan. First, we'll look at the threat itself. Then, we'll get into why drying these chemicals is so absolutely critical. We'll touch on the science behind it, see how it's done out in the field, and finally, wrap up with the huge benefits of keeping things pure. Okay, so here's the deal. We rely on inhibitors like methanol and glycol to stop gas hydrates from forming in our pipelines. Think of them as nasty industrial ice plugs. These chemicals are our first and best line of defense. But that defense is constantly under attack by plain old water. And what's wild is just how unavoidable this is. These chemicals are hygroscopic, which is just a fancy way of saying they are powerful sponges. They literally pull moisture right out of the air. It's not a flaw, it's just their chemical nature. So you factor in wet gas, storage tanks, simple condensation, and you realize this isn't a risk, it's a certainty. Water is always trying to get in. And believe me, the damage it does is huge. When these chemicals get diluted, they just don't work as well, which means you're gambling with blockages. Even worse, that water starts to accelerate corrosion, literally eating away at your assets. So you're forced to use more chemicals, which drives up costs, all while your entire system gets less and less efficient. It's a really vicious cycle. So if water is the problem, then getting it out is the solution, right? And that's why drying isn't just some routine chore. It's about restoring the full power of your most important chemical defenses to protect the entire operation. I mean, just look at the difference here. It's night and day. On one side, you've got wet chemicals, ineffective, corrosive, and expensive. And on the other, you have dry chemicals, effective, protective, and efficient. You're basically choosing between a system that's constantly at risk and one that's operating at its absolute peak. And to really put the required precision into perspective, for methanol, the target is less than 1/10 of 1% water. Think about that for a second. Anything more than that tiny, tiny amount, and you start losing your protective power. It's the same story for glycol, just as demanding. Here, we're aiming for over 99.5% purity. Hitting these incredibly high standards is the only way to restore the chemical's full power. It's truly a game of microscopic margins. So how in the world do you actually achieve this level of purity out in the field? Well, this isn't guesswork, right? It's a whole suite of advanced engineering technologies designed to target and remove water molecules with incredible precision. The method really depends on the situation. For just polishing up smaller volumes, you might use a molecular sieve, which acts like a microscopic strainer for water. For glycols that are sensitive to heat, vacuum distillation is perfect because it gets the job done at a lower temperature. And for the big, large-scale systems, conventional distillation is the go-to workhorse. It's all about using the right tool for the right job. Okay, so we've got the science down, but how does this actually play out in the field? Well, it all comes down to a systematic, quality-controlled process that takes that science and makes it reliable and verifiable in the real world. It's a really meticulous workflow. First up, you take samples and analyze them so you know exactly what you're dealing with. Then, based on that data, you choose the right strategy, the right tool for the job, like we just talked about. From there, you implement the process, circulating the chemical through the drying unit. But it doesn't stop there. Afterwards, it's polished and filtered to get rid of any other gunk. And finally, the most crucial step, rigorous testing and certification to prove with cold, hard data that you've hit those purity targets. So, we've walked through the problem and the whole process. But why does all this matter? Well, the payoff for getting this right is just enormous. It touches every single critical aspect of your operation. You can really boil all that value down into 4 key areas. We're talking enhanced reliability, serious cost reduction, improved safety, and some real environmental benefits. Let's just quickly hit each one. First up,
Reliability. And this is the big one, folks. Dry chemicals mean no hydrate blockages. No blockages mean uninterrupted production and consistent flow. It's the absolute definition of flow assurance.
Next, you've got savings. By restoring your chemicals, instead of just replacing them, you slash your consumption. And by getting that water out, you minimize corrosion, which extends the life of your expensive pipes and tanks. This hits your bottom line in two ways: operating costs and capital expenses. Then there's safety, which is completely non-negotiable. Those hydrate plugs can cause incredibly dangerous pressure spikes in a system. By preventing the plugs from ever forming in the first place, you eliminate a major operational risk and just create a much safer working environment for everyone. And last but not least, sustainability. Instead of just disposing of contaminated chemicals, which is expensive and wasteful, drying lets you reuse them again and again. This cuts down on chemical waste and supports a much more circular, responsible way of operating. This quote right here really says it all, doesn't it? Drying isn't a nice to have. It is a critical service. It is fundamental to preventing hydrates, keeping things efficient, and at the end of the day, protecting the very integrity of your assets. All right, so let's boil this all down. If you remember just 4 things from all this, make it these. Water is the hidden enemy. Professional drying is the precise solution. It's a systematic process that delivers results you can count on. And the benefits are crystal clear: a more reliable, safer, and cost-efficient operation. So I'll leave you with this one final thought. When you really consider the silent, hidden threat of water dilution, is your first line of defense, those critical chemicals flowing through your system, truly as strong, as pure, and as effective as it needs to be?